My voice clear tak?
Clear.
Sebab kalau kita ni tak berapa clear pada line. Oh, boleh tak ada masalah. Bila test kalau if my voice not clear, just mention to me because sometimes the line is not go so good.
Oh, okay. Mr. James, can you hear me? Because we cannot hear you. Mr. James, can you please unmute your mic because we cannot hear you? Okay. Okay, sorry everyone, we're having some problem here. Okay, please wait.
While waiting, I off my camera for a while.
Okay, while waiting for Mr. James.
Yes.
Hello, Mr. James, are you there?
Yes, I'm here.
Oh, okay.
Okay.
Alright, okay. We are good, okay. I think we can start now, right? And before we start, I would like to please set all participants, please set your microphone to mute, okay? Okay, Assalamualaikum and good afternoon, ladies and gentlemen. Welcome to the webinar organized by Green Energy Research Center, GERC, and Solar Photovoltaic and Conversion Technology Research Application Spectra. Thank you for joining this webinar. I'm Adika, and it is my delight to be your MC for today. To kick off this program, we are pleased to have with us the head of GERC, Associate Professor in Senior Technologies, Dr. Sharil Irwan Sulaiman, to deliver the welcome speech. Please, Dr.
Hi, Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone present. So it's raining outside my house, so I hope it's not too noisy there. Respected Associate Professor in Senior Dr. Ahmad Farid Abidin, Acting Dean of Faculty of Electrical Engineering, University Technology Barat UiTM Selangor, Malaysia. Associate Professor Dr. Hazlin Zainuddin, the Head of Solar Photovoltaic Energy Conversion Technology Research Applications, or Spectra, from Faculty of Applied Sciences, UiTM, Malaysia. Our guest speaker today, Mr. James Lee Chung Min, the Solution Director of Malaysia Enterprise Business Department of Huawei Technologies Malaysia, Sdn Bhd. So this is my first time also meeting you face to face, Mr. James. Moderator of the talk today, Professor Dr. Sulaiman Shari, a member of GRC, Spectra, and also from Faculty of Applied Sciences of UiTM. Distinguished guests, my dear students, and also ladies and gentlemen. So today we all have gathered here in a virtual platform to discuss about a very important topic, smart inverter technology updates. As we know, inverter is an essential power electronic equipment in photovoltaic systems, whether in grid-connected or off-grid systems. In fact, inverter is frequently deemed as the brain or the heart of the PV systems. Okay? So starting with power conditioning equipment, the function of inverters has been diversified while their features have been improved to ensure smooth and safe operation of PV systems. So therefore, realizing the importance of inverters as part of PV system components, this webinar is held to disseminate the latest information and to discuss on issues related to smart inverter technologies for the use of PV systems. So with this brief background, on behalf of the organizing committee from Green Energy Research Center of Faculty of Electrical Engineering of UiTM Malaysia, I would like to welcome our guest speaker, Mr. James Lee Chung Min, the Solution Director of Malaysia Enterprise Business Department of Huawei Technologies Malaysia, Sdn Bhd, for being able to share his expert knowledge and also information and also views on this pertinent topic. Okay? I also feel honored to welcome Associate Professor in Senior Dr. Ahmad Farid Abidin, the Acting Dean of Faculty of Electrical Engineering, for being able to spend his valuable time to this webinar. So besides, I would like to welcome all of you participants, regardless of where you are. Okay, so I can see from the list, we have good compositions of participants coming from the universities, okay, not only from UiTM. So we have also participants from research institutions, government agencies, and also PV industry. So welcome aboard. So I would like, on behalf of the organizing committee, again, thank you for accepting out the invitation and participate in this short webinar. Okay? So before I end my speech, I would also like to extend my gratitude to Associate Professor Dr. Ahmad Farid Abidin for encouraging us to conduct a webinar like this today. So thank you for your kind support and also suggestions. So I would like to express my appreciation also to all members of the organizing committee for your effort to make this event happen. Okay? For your information, this webinar is jointly organized by Green Energy Research Center and Solar Photovoltaic Energy Conversion Technology Research Applications, or Spectra, of UiTM Malaysia. So I'm sure that you all will feel enlightened or enriched with knowledge upon the completion of this event. So before I end my speech, I welcome you all once again to the webinar and hope to see you again in future webinars. Thank you. So I pass over.
Thank you, Dr. Sharil, for the welcoming speech. Next, we are pleased to invite Associate Professor Insigne Dr. Ahmad Farid Abidin, the Dean of Faculty of Electrical Engineering UITM, to deliver his speech and also launching the webinar. Please, Dr. Farid. We are pleased to
Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Thank you, Mrs. Atika. Respected Associate Professor Dr. Syariwan Sulaiman, as the Head of Green Energy Research Center GRC, Faculty of Electrical Engineering University Teknologi Mara, UITM Selangor. Associate Professor Dr. Hazlin Zainuddin, Head of Solar Photovoltaic Energy Conversion Technology Research Application, Spectra, Faculty of Applied Sciences, University Teknologi Mara. And our respected invited speaker today, Mr. James Lee Chumin, Solution Director of Malaysia Enterprise Business Department, Huawei Technologies Malaysia Sdn Bhd. All distinguished guests, my dear students, ladies and gentlemen. It's a great honor for me to welcome all of you again to the webinar of Smart Inverter Technology Updates. This webinar organized today is part of the initiative taken by the Faculty of Electrical Engineering of UITM on promoting the sharing of information, knowledge among faculty members, researchers, students, external institutions, including industries. And we know that the pandemic has made us rely on process in universities. Using this, Green Research Center GRC has taken a good initiative to choose a topic which is important for the implementation of photovoltaic system worldwide. We know that in Malaysia, the number of installed grid-connected photovoltaic system have shown a very promising trend for the past decade since the inception of Renewable Energy Act 2011. And of course, similar positive trend happens worldwide, with the total global capacity already reaching more than 600 gigawatt in 2020. And one of the key factors that drive the implementation of photovoltaic system is a smart and reliable system component, which includes inverters. Therefore, I hope that this webinar will help the participants to be up to date about the latest trend, features in smart inverter technology, which is used in photovoltaic system. And again, I would like to express my gratitude and thank you for Mr. James of Huawei Technologies Malaysia Berhad for your kind and willingness to share your knowledge and view of the topic. Thank you also to all of you for your participation. Before I end my speech, I would like to congratulate all members of the organizing committee from GRC and of UITM for holding such resourceful webinar. Thank you. Over to you.
Okay, thank you, Dr. Farid. Ladies and gentlemen, it is now time for us to listen to the exciting topic about smart inverter technology update. I would like to remind that you can type all the questions in the chat box and our committee will read out all these questions for Q&A session. Before we start, I would like to introduce our speaker of the day, Mr. James Lee. Mr. James Lee is the Solution Director of Huawei Malaysia and has been in the solar PV industry for more than 10 years. He has accumulated rich experiences from project development to operation and maintenance. From this, he brings along a holistic approach in providing value-added information and services. The floor is yours, Mr. James.
Thank you so much, Atika, and thank you, everyone. First and foremost, I'd like to thank Dr. Sharil, Prof. Sulaiman for the invitation, along with GERC and Spectra. I truly hope that today the session will be both useful, informative, and beneficial in terms of understanding what the trends are in today's solar PV system. And as mentioned by even Dr. Farid, that the solar PV the inverter is one of the key components in the entire system. It usually is noted as the heart and soul or the brain of the system. So therefore, it is very important for us to really get a good understanding of the latest technologies, trends, as well as what are the latest updates coming with this. So without further ado, I will, share my screen. Let's see here, if I could. Is everyone able to see my screen? Good to see ya. Okay, perfect. So, without further ado, I would like to start with just a little bit of introduction to Huawei. Simply because most oftentimes when we think about Huawei, we think about telco, we think about cell phones, laptops, and so on and so forth. But Huawei actually has been in the solar PV industry since 2013. So not quite yet 10 years, but in that short span of time, we've been able to make leaps and bounds because of a lot of things in relation to our commitment to innovation and research and development. So with that, you can see from this slide here, almost 50% of our employees are dedicated towards R&D. And that's why we are able to leapfrog amongst all the other different players in this industry, notwithstanding also 5G. I'm sure we all have heard about the whole debacle with the United States and their fight against the spread of the 5G technology that is presented by Huawei. But yet, even in such trying times, I'm very pleased to say that we have a very steady growth. Last year, our estimated revenue was close to 136 billion. So year-on-year growth is about 11%. So why we mention these kind of data is because it is important to also see the company's longevity or the ability to stay in the market. As you know, solar PV industry is a very volatile market. It fluctuates a lot. There are entries and exits of companies and players faster than most other industries. So as we know that ABB has already exited. They've sold over to Femur. Schneider has downsized only to string inverters. So this is again showing the volatility and the strength of the company and the capability of the company in order to withstand such trying times in the industry, especially. Furthermore, with this, as I mentioned earlier, we've only entered the market since 2013, but since 2015, we've been ranked number one in terms of our global shipment. And to date, as of the end of 2020, we have about 158 gigawatt of accumulative global shipment. Just a little bit of introduction to our team in Malaysia. So I believe that this is actually a very large team that we have for any inverter company in Malaysia, to be honest. And there's a very high localization rate, as you can see here. About 50% or more actually of us are locals. So we believe in local talent, in building local talent, and also to ensure the seamless delivery of our solutions and services to our customers in Malaysia. Here, a little bit more information also in terms of how we support you as our customers. We have obviously all the different warehousing facilities that will be able to give us that capability to ensure that we can service you as our customer. So without further ado, I will now look into the solar inverter itself. As some of you all may know, we do not provide central inverters simply because we believe in the string inverter technology, and more importantly, because string inverter technology really lends towards power electronics. And although central inverters do have portions of it, but in terms of innovation and in terms of the application of central inverter, you won't be able to do that in a residential home or in maybe some small commercial industrial kind of a rooftop space. So string inverters really represents a lot of flexibility in terms of the capability of suiting and matching all the different scenarios and rooftop spaces or sites. So now I'd like to share a little bit about the trends in the energy sector. Believe it or not, the first power plant was built in Paris in 1875. And since then, we have moved from, actually wind was one of the first few REs, but it was not effective and efficient in terms of delivering high-powered or high amounts of electricity. Then, of course, came nuclear power. And then in 1969 was the first solar PV plant. But as you know, back then, the panel is very inefficient. And again, you're only able to generate a small amount of energy with a substantial space. And then, of course, in 2016, with the signing of the Paris Agreement, which the United States have just recently entered back into, we start to see that there is a boom in and focus shift, a paradigm shift towards renewable energy. And so now in the future, what are we looking at? We're looking at a mesh, an intertwine of a lot of different things such as electric vehicle. We're looking at industrial power consumption, electrification. We're looking into electricity trading, energy storage. I think that this is the final frontier for solar PV because it will provide not only stability, but also the capability to generate at night. So this is probably one of the most exciting things that we are hopefully going to look into. And of course, this is not going to be the main topic of my sharing today. But we will definitely be more than happy to share our solutions in other times should we be invited once again. But more importantly is this, the digitization and the inclusion of artificial intelligence is what will be able to provide the interconnectedness between all these different requirements and all these growing needs and also advancements in terms of additional items to the grid such as electric vehicles. Yeah, and here are some of the main key trends that we will see within the next 5 years, well now 4 years since we're in 2021. As I mentioned in the beginning, is the digitization. So a lot of it will be Internet of Things. We're trying to make the system, the power plant more intelligent, more efficient and effective in terms of your O&M, and also to manage the plant in a very streamlined process. Yeah, it's very important for this because solar PV has also been given quite a bad rep in terms of the ability to survive in the length of time that it's supposed to be designed for. So for example, a lot of PV systems are actually having a lot of problems in the first 5 years alone. So, but then this is where we are trying to ensure that you have the necessary tools through digitization and artificial intelligence in order to cater for and cope for these problems. The next trend, of course, is that we are looking at different optimizations like tracker systems, fault diagnostics, and then of course the storage collaboration. This is also quite interesting in terms of what is there in the trends to come. The next one is unmanned power plant. Now with COVID, with the recent COVID situation, we've not been able to go out as much. And in this case, of course, this power generation is a critical service, so you would be able to get that pass. But at the end of the day, we want to provide that capability of reducing the manpower required in order to manage the plant, or to streamline it so that it will be more efficient and that you'll be able to tackle the problems in a more timely manner. The next one we see is that the short circuit ratio. Now, I think this is also going to be very interesting, which we are hoping to go into a greater detail with the utility company, with Suranjaya Tenaga, because we see that the short circuit ratio in various countries are reaching in levels whereby it is requiring more stringent requirements in terms of low voltage right through and so on and so forth. Later, I will share with you a case study of what happened in China, whereby the additional inclusion of a new PV plant has caused a lot of problems in terms of the short circuit ratio. The next part is, of course, the photo storage symbiosis. So this is energy storage as well. I've done quite a few presentations already on our residential storage system, so I will not again go into depth in this particular session because we are looking at inverter technology. But remember, the inverter, as I mentioned in the beginning, in the introduction, is that it is the heart and soul and the brain of the system. So everything else will be tied back through the inverter. And so that's why we are terming it now as our smart energy center. And last but not least, of course, is the virtual power station, which I believe we've been trying to implement. And hopefully in the coming months to the year, hopefully we will see something materialize from it. Now I'd like to share with you a little bit about what the inverter technologies that we are trying to bring into this industry and into this field. The key things that you will see that I'll highlight are such as higher yields, smart O&M, safe and reliable systems, and last but not least, grid supporting. So for us, and in terms of inverter technology, the first thing I like to highlight is that we are trying to remove intermediary components such as combiner boxes. So you can see here there's no DC combiner box, no AC combiner box. It is directly through the transformer station. Now this is of course the application of large scale. In for rooftop application, of course you have MSB or your SSB, depending again on your design. But the most important thing is that we believe that reducing and simplifying the network will enable you to have a more robust and more reliable system, and therefore you'll be able to achieve high yields, smart O&M, and so on and so forth, as I mentioned earlier. So in terms of the smart string inverter, the other portion for large scale we introduce is of course through the communication of power line cable communication, or what we like to call monitoring bus. Yeah. So these are a few of the things that I like to highlight, and I will go into greater detail. Now let's look into the technology in terms of achieving higher yields. Now MPPTs is a very common knowledge. I think everyone more or less have heard of this term. It's basically a multi-point power tracking, and what it does is to find the highest knee point of the curve, of your IV curve, in order to get the best generation. So again, for Huawei, the introduction of AI in terms of the algorithm and our hardware coupled together, we are able to therefore achieve a higher efficiency. So this in itself is one of the key things in terms of ensuring that the PV plant is able to produce at its optimal level and at its maximum capacity. Without this dynamic efficiency of the MPPT, you would see a reduction. So this reduction may be seemingly small, but in the long term, it actually adds up to a lot. So this is the first capability that I like to introduce in terms of MPPTs, but more importantly in terms of how fast it is, and that is the efficiency part of this MPPT capability. Now, why is it important? So now I'm giving you an application of it. In this case, I will look at floating solar. I mean, floating solar is quite new, relatively new in Malaysia, and I believe we have one and coming maybe two more large scale that it would be coming online. And one of the studies that has been done, this is WIML, which is basically wave-induced mismatch losses. So in this case, because of the conditions at site, which is very, very turbulent at times with strong winds, and it is of course at dams. So dams usually is a catchment area, so you would have that strong wind tunnel effect. And there's a study, this is done by another third party, and they did the study and they found that this kind of a loss in yield can be add up all the way to 9%. Okay, so why is MPPT therefore in terms of its efficiency important? It is because in order to cater for this problem, we need an efficient and quick algorithm and capability in order to address this mismatch due to the wave-induced losses because of the buoyancy and because of the floating platform moving back and forth. Yeah, and this is again, like I said, these are the height of the waves. So again, as it gets more severe, and this is actually not unheard of. Yeah, I mean, I've been to some of our dams in Malaysia, and they say that it can reach up to 1 over meter with strong winds. Yeah, of course, we're not talking about rainy season because the generation is not really a key concern. But yeah, during windy conditions, yeah, you would see this as a point as well. So here's another case study that I'd like to share with you of the importance of this MPPT efficiency. Now, this again is a comparison, and in China, as you know, they have huge plants, and these plants, they are able to do a very nice side-by-side comparison because their plants are of large capacities, 300 megawatt up to 1 gigawatt. So in this particular study, or rather a comparison, and this is again with other string inverters. So now I'm not even talking about central inverters, which only have 1 MPPT per inverter. And with this, you can see that the benefit is actually, we always like to understate it. We say it's anywhere between 2% or more. Yeah, and in this case, this was 3.16%. And as you can see, the land is very undulating. So therefore, the MPPTs play a vital role. And so therefore, in terms of advancement in technology, although MPPT has been around for a while, but again, the algorithm, the hardware, as well as the introduction of AI lends towards the optimization in this area. The other part which we like to share about is also about about tracker systems. As you know, we are a telco company, and for us, we are able to actually work with certain vendors of tracker systems in order to help with the algorithm and management of the tracker system. So the traditional tracker system, as shown from the first picture up here, you can see that it's a uniform movement, and maybe because of the cost of leveling the land, sometimes the land may be a bit undulating, so it's gently undulating, but still there may be shading factors that are caused by the array in front of the one that is affected or impacted. So for us, what our algorithm does is that it does this cycle here on model sampling, and then it does its AI training modeling to then employ the algorithm, and then it continues to self-learn as the production of the optimization of the production based on the or rather not mismatch, but rather of the mistimed tracker system. So we are no longer doing it uniformly. We are actually specifically controlling it to minimize the shading factor as best as possible. Okay, so here is a very good flash video just to illustrate that fact. And this is also on the sloping side. So you can see the shading that occurs during the morning. And this is based on a standard design where it's all uniform. But with our artificial intelligence, you can see here that we are able to interrupt the panel tracker system in order to ensure that it does not cause the shading. So you can see it's no longer uniformed. Yeah, and from this, we have actually found the additional yield gains as low as 0.5% to over 1%. So you can imagine with your MPPTs and efficiency now coupled with this capability of negotiating and to then change the signal in order to have a different ununiform or non-linear kind of this is PID. Now, PID has, I think, the panel manufacturers have tried a lot in terms of reducing this impact. Now you can see there are a lot of panel manufacturers saying that they are either PID free or they are PID resistant. But nonetheless, we've seen even with these panels, it's not 100% foolproof. But for us, we actually have a PID prevention. So this is for large scale, of course. For our rooftop, we have PID recovery. The reason being is because of the type of earthing system. For our PID prevention or anti-PID system, it is a IT or floating earthing system. Whereas, of course, for your low voltage connected systems, you would have a neutral line which does not enable this kind of PID recovery or PID prevention. So how we did was we learned from, in theory, what PID does and what was the impact in terms of the negative potential built up on the negative polarity of the panel. So after doing a lot of research, even research by this Arizona State University says that it cannot 100% recover the degradation. And again, they even another university found that this degradation could be 15%. During my time as EPC, I've actually personally seen up to 30% within the first 5 years. So this PID phenomena is actually quite detrimental to your investment as well as production of generation of energy. So for us, when we took all of these researchers and we tried to figure out how best to address it, we did a 31-day on-site test in China, of course. Dongguan is where our factory is and where our facilities are. So you can see here in terms of the comparison, we had one string which is normal, it's our control, and then you have, of course, string 2, which we try to speed up the degradation, and then normal condition, so on and so forth, to try to subject it to give the different kind of variations that may possibly occur at site. And then, of course, last but not least, string 4, we have the PID prevention with no normal condition, but a speed up degradation condition applied to that string. And what happens is that we found that our PID prevention compared to PID recovery is 3% higher. And more importantly, in comparison to the non-PID protected system, it is significantly higher. Yeah. So once again, these are different technologies which we are trying to bring in because we want to ensure that the investment in solar PV is a sound investment. Imagine if investors were to learn of their investment reduced by 30% in the first 5 years. The whole entire financial model is no longer viable for such investments. Here is another case study that we did in terms of our PID recovery, and we did this at a fishery. Okay, so just a little bit more background, if I may backpedal a bit. PID, the incidence is right actually because of few factors: high humidity, high temperature, and of course high soiling, which in Malaysia we have all three. So these conditions are what will accelerate this PID impact. So as you can see, this is done at a fishing PV integrated plant. And you can see here the humidity is very high. The temperature may not be as high, but even so, and this is a study that was conducted by TUV, verified by TUV. So you can see that the modules without the PID were severely impacted by this. You can see that the negative polarity, the negative charge, the voltage is very high here. Whereas when we have a PID prevention enabled, you can see that it's operating in the range where it should be. So this test in and of itself proves that that our PID module and PID prevention system works. Yeah. The next one I'd like to share with you, of course, is that we also always like to verify via TUV that in terms of failure rate. I think that is, although it's not really technology kind of a thing where you can quantify it, but it is important to note about the failure rate in terms of your higher generation. Now I would like to go on to the rooftop side a bit, because again I spent quite a bit on solar farm. So here, as you can see, we are also trying to introduce optimizers. So the nice thing about optimizers is that you can see in terms of rooftops, you cannot choose the rooftop that you're going to build on or that your system is going to be on. And whatever the features or structures that are already pre-existing will always be there. And therefore, there will be a constant shading factor that will occur throughout the day. As it goes, you can see that the shadow may come closer. So in this case, the optimizers will be able to enable you to fully segregate all the performance of the panels into its individual module level. So you can see in this illustration here, without optimizers, there is aggregation that occurs to all the strings that are connected to this shaded module. Whereas with the optimizer, the rest of the panels will perform optimally to whatever conditions that they are subjected to, whilst the ones that are shaded will only be impacted accordingly. Yeah, and then the other innovation that we bring in is this long string idea, whereby with the use of the optimizer, you are able to actually have a higher DC-AC ratio oversizing. But more importantly is that you can also work with the kind of layout that is at your site. So sometimes you may need, like especially for residential rooftops, I see this as a very good point, because you've got so many orientations of your rooftop, and so therefore you don't want to be pulling so many cables down to the inverter it is another point of failure. It's also a point of potential risk of fire hazard. So with this long string and with the optimizer, later I'll share with you a little bit more on the safety of how optimizers can bring more safety to you. You will just need to string one whole entire string back to the inverter, and away you go. You have one point only to concern yourself with. The other part, I think, which was mentioned to me to talk about a little bit, is the high current modules. So high current modules, as you can see from this particular table here, again, depending on the panel, these figures may change or vary. So for us, we believe, as you can see, and I'm using this as a rooftop case scenario, because the large scale, we definitely have the solution and it's quite straightforward. But with the commercial and industrial rooftop solution, you can see here, first and foremost, I like to highlight our maximum current per MPPT is 26 amp. Our maximum short circuit current per MPPT is 40 amp. So from here, you can already see that in terms of its operating current, we are well above the panel if you're talking about just one string. Yeah, and then of course, in terms of the ISC, also we're still well above it, right? And the reason why that works is because instead of utilizing all the inputs per MPPT, now all you need to do is to use one input per MPPT, and you will be able to solve that issue. Because at the end of the day, if you were to use all the inputs and per MPPT, so 2, so that means 20 inputs, you're going to have a DC-AC ratio which is quite ginormous. And again, it may not be as practical, and I don't think it's worth your investment to throw money into DC, whereas your AC is capped already. So in this case, all you need to do is to do that, fill up one input per MPPT, so you've got 10 MPPTs, 10 strings, and your DC-AC ratio is already reaching at 1.33. Yeah. So, and the other part I like to highlight, so as you can see here, the VMP is 34.8. So if you multiply that by 22, it's about 700 odd VMP. So when you also then include the temperature coefficient, and we just use a general rule of thumb, maybe 10%. So you are actually able to operate. The inverter is able to operate at its highest efficiency, which is in the range of about 620 volts, right? So when you bring it back down, you are well within the range of the higher efficiency. So a lot of times when people design, they just look at what is the maximum string length that you can do in terms of the panels per string. But oftentimes we also need to consider, or if we really want to optimize the system, is to look at the efficiency curve of the inverter. And a lot of times you will see that certain inverters, especially for central inverters, may not reach the maximum efficiency capability, depending on your string design as well. Now with the high current, it changes the landscape a lot. You can see that the VOC is actually pretty much there, but the current has increased significantly. The VOC actually has dropped quite a bit. Some panels were last time 46, whereas the current was maybe say 12. Yeah. So there's a lot of change and change in terms of the way how we design the solution. So in this case, we already have the solution because we actually plated for bifacial. So you can see our current rating is a lot higher. So I hope that this addresses some of your concerns in terms of using these high current modules with our inverters, or with the inverter technology anyways. So the other portion is that for what I like to bring to you is that what is these innovations that we bring. As you know, string inverters, one of the key things is that we can monitor it at the string level. Yeah, and furthermore, again, accuracy is important, and therefore we always look at the accuracy of the sensors in order to ensure that the information delivered to you at the monitoring system is reliable and accurate. Yeah, so therefore you'll be able to see and manage your plant in a more effective manner. And then here is, I think, one of the key things. I know that there are other IV curve scanners out there that are built in with the inverter, but for us, we take pride in because we usually have it TUV certified as well. Yeah, so TUV has verified that our IV curve has accurately detected up to 14 types of panel failure. Yeah, and so you can see here from some of the projects globally, and even here in Malaysia where we try to run it as well. This is of course during the teething period. So when we first energized the system, IOD, this is the best part of this tool. This is where you'll be able to collate At a click of a button, within 10 to 15 minutes, a report is automatically generated for you, and all the tests such as your ISC, VOC, IMP, VMP, everything, all the data will be given to you in that report. And so from there, you'll be able to then identify certain panel failures. And we found through this 7 gigawatt over worth of applications that one of the top 4 module failure types are string short circuit, abnormal output current, string current mismatch, string voltage abnormal. So these things are not commonly easily seen by the naked eye, and you would have to have a thermograph scanner in order to identify the hotspots or whatever signs that indicate to this. But why worry about that when you have a tool that will be able to pinpoint to you the exact location at the string level for you to then only look at, say, 30 panels and work your way along to see how to rectify the problem. All right. So we don't only just tell you what is wrong with it, we also tell you how to solve it. So we do prescribe the steps. So this is again innovation that is brought in, coupled with my earlier slide, which I said here. First, high accuracy in terms of its monitoring capability, string level capability in terms of its level of monitoring. Then with this, coupled with this added feature, you have a winning solution to give you the tools necessary to manage your plant in the most efficient and effective way. Furthermore, we also bring to you this MBUS, which I mentioned earlier. So I want to share a bit about what is the key advantages. First and foremost is that you do not need to worry about additional cabling to enable that string level monitoring. It is all carried through the AC cable, and the AC cable is far more reliable and more robust, and it's buried underground. Whereas your RS485 is very prone to failure, it's very unreliable, lightning strike is a big problem to it. In terms of the transference rate, now this is something that was quite interesting because the initial problem that most people had with string inverters is that for last time back in the day, for a 50 megawatt plant, our small inverters, at that time was the biggest, you needed about 1,200 inverters for a 50 megawatt plant. So how about the communications? How about the grid response time? Because of this MBUS capability, which we've already had from the day one that we implemented for solar farms, you can see the transference rate is very high. And more importantly, it is transferred to its nodal points of where the transformer stations are. So every time it's actually negotiating with only X number of inverters. So our current solution now is 32 inverters at any given time. So therefore, in terms of the ability to respond to the grid, we are actually in the milliseconds, which is well above the requirements by the grid utility companies. We have zero maintenance, it's more robust and reliable. Okay, the next part we like to talk about is, of course, in terms of technology, you also need to look into the power electronics portion in terms of the manufacturing. So for us, we look into very strict and quality control. Yeah. One of the key things that I like to highlight is this portion here. In terms of the internal circuit design, based on IEC 62109, this crimpage distance is basically the distance between all the components within a PCB board. And so you are supposed to have a certain distance in order to ensure that it does not cause interference, it does not cause a weak point, it does not cause potential for failure. So this is something that we really pride ourselves in, and because our production line is fully automated, accuracy is definitely well maintained because it is not done by human labor. It is all done automated. Okay. Because this is a very strong testament to our commitment towards providing quality products. Now, how does this tie into inverter technology? Well, as you know, we are talking about SPDs here, okay? If you haven't guessed yet. So SPDs are a key feature that is important in order to ensure that your inverters are able to withstand certain lightning strikes. Now, I'm not talking about a direct lightning strike. I'm talking about a aerial effect, yeah? So inductance of the due to the lightning strike. So here we have a rocket triggered lightning. In order to elicit that particular strike, and we have testing of our components here right at the site in order to show, as long as you have a very good lightning protection system at site, the SPDs will do the rest of the job in order to protect your system. Yeah. Of course, we also go through a lot of stringent tests at the lab, but we also do a lot of tests on site and on the field. Yeah. So here, in terms of quality check, again, the production is fully automated. So I think inverter technology. When you talk about the inverter technology, we also have to talk about the birth of the inverter, the actual process that goes into producing that unit itself. So these are some of the things that we would like to share with everyone in order to see what are the differences in comparison to all the different manufacturers here. Okay. The other part is of course now we're looking into safe and reliable systems. PID. There are PID recovery systems or prevention systems out there as well from other suppliers, but the danger is that their PID module is actually on the DC side. Now, what happens when that kind of design is implemented? First and foremost, it is high risk to electrocution of your personnel operating the inverter or at site, because of the fact that the RCD is on the AC side, and because if there were to be a leakage current, the RCD will never capture it, because it's not on the side where the PID module is actually doing the job of doing the grounding, the negative grounding, to reduce that or to protect against the PID impact. So you can see here the grounding point is in between the PID module and the RCD. So it will never go into the RCD to therefore give that protection that is required. And therefore, when a person accidentally touches the current, they basically close the loop and they get electrocuted. Whereas for our design, we do it on the AC side through the use of our additional component, which is the smart array controller unit. So the marriage between these two items, again, will bring you a higher and more reliable system. So, of course, we want to preserve the system in terms of making sure that it is optimized, it is going to match what our modeling is, but we also want to make sure that it's safe for your people to operate, or for people to operate. Yeah. So, and again, this is also prescribed as per the standards of the international community, IEC 62109. Okay. Now, the other part about the inverter technology, which I think now has become quite a bit of a buzzword, is the AFCI, arc fault circuit interrupter. Okay, what is arc fault circuit interrupter, and what is it trying to address? Basically, the name suggests it all. It's to detect the arc that occurs if there were a severance of cable, whereby this is a very dangerous point and potentially a source of fire outbreak. So this particular AFCI function, we believe that it's very important for the CNI scenario or rooftop scenario, simply because your rooftop, if the rooftop catches fire, there is a negative impact to not only the operations and production and assets below, but also potential loss of human life. More importantly, even so, for residential homes where you have children, you have babies, elderly, this is a very, very important point. And I think I've conducted webinars last year, and I've always emphasized on this, because I believe that we cannot afford the industry to get a bad rap should there be, God forbid, that there is any untoward instances of fire due to solar PV, and it has certain accidents that occurred that, basically it's going to be bad for the industry in terms of confidence level as well. So for us, where do these sources of arc fault occur? It's at the solder joints within the modules. It could be due to the broken cables, as I mentioned earlier, or even the PV connectors. There are also human error as well that can be involved as well. These are just some of the main key areas. But what are the challenges? This arc noise actually generates a very weak signal, and this weak signal therefore has to be recognized and to be addressed immediately. And it's actually 0.1% only. So therefore, it's very difficult for most systems to identify and to be reliable that way. The other part is of course, there's a lot of interference that occurs because of other things like you have things above like your communications, telco, and so on and so forth. So let me speed on a little bit here because I know we're running a bit out of time. I do apologize. The fire incident. Okay, so for us, our AFCI, we are above their standard requirements by even UL and now the new IEC standard. The other part which I mentioned earlier about the optimizer is that we have module level STRATOM with that capability, so that's a high safety feature. And the other part is that we can actually pinpoint the location with optimizers at the exact module level. And here is just to show you what's more about TUV certification. We always make sure we verify what we claim. The other part about inverter technology is that for our inverters that are from 60 kilowatt and below, we do not have any fans. And that's because we actually have we borrowed the technology from our telco site, where we've had a lot of experience. And as you can see from the pattern of our heatsink, it is very different and unique based on our analysis of the heat distribution in the internal components to bring it out. This is the grid supporting, which is my last area of topic of discussion. Again, I think that as there's more penetration of PV systems or renewable energy systems, short circuit ratio will become a key factor, and some of the big grid supports is down to even 1.5 SCR. And because of that, the fault right through capability has to be increased and improved. And of course, your power quality also has to be a lot more stringent. So here is some of the comparison tests that we did in a WIC grid. So I will jump now to the case study itself. So in China, there was this particular plant. It was 100 megawatt, and then they added on our PV plant of 20 megawatt. So you can see here the SCR calculation was before the additional 20 megawatt, it was 2.17. After the addition of the 20 megawatt, it went down to 1.85. And then during this time, what happened was that there was a low voltage right through, and this whole entire system tripped. But whereas for our system, it was able to ride through it. So once again, this is about grid stability, and supporting the grid. And what happens is that it's a domino effect, because as this goes on and there's more renewable systems going in, you will see that it will cause a domino effect of all the other plants tripping. And this is again another testament of what AMO, basically in Australia, there are very stringent requirements, and they actually have issued out a letter to state that our HVRT and LVRT are able to pass their requirements. Okay, let me just go to, I just have a few more slides, sorry if I may. And last but not least is, of course, in Malaysia, we had a reference site, and the IV curve that I told you about, so I want to share that that particular plant operated for 1 year, and within that 1 year, they changed over 263 panels. This is obviously their letter stating and verifying the information that I've just shared with you. And this is again a recovery based on, because we were able to identify it earlier. But if it wasn't because of that, this value will obviously increase. So would this as well. So here are some sites just to show you all some pictures of all the different sites that we've been in Malaysia. And with that, I thank you all, and I do apologize if I did run over time. So I'll turn the time back to the floor and to Atika. Thank you.
Thank you very much, Mr. James, for your sharing. That's so informative, and I am sure our audiences learned a lot from you. Okay, without further ado, I would like to invite Professor Dr. Sulaiman Syari as the moderator for the Q&A session. Please, Prof.
Thank you, Ms. Atik. James, welcome back. Nice to see you back. We have
Thank you.
We have a very interesting set of questions. Since we don't have too much time to discuss a lot of things, what I can suggest now is I would like you to respond to the questions quickly, because we have only a few more minutes left. So it's in the chat box.
Okay.
Can you please respond starting from the first question? I won't read them. You can read them directly. So
Sure.
Huawei efficiency rate, yes?
Okay, no problem. Okay, so the first question.
We'll start with the first one because it appears there first from Dr. Sharil Irwan. Please respond to that question.
Yes, correct. Okay, so the expectancy of modern inverters, we actually had an independent study done by DNVGL, and for our particular inverter, they verified at least 16 years, and then the subsequent years with repair. So of course, not all inverters will fail all at once in after the 16 years. It's not like there's a timer and then it just expires. But as the subsequent remainder of the life of the inverter, it will be subjected to repairs in order to maintain it. Yeah.
Okay, thank you, James. We have about 10 minutes to answer all of these questions. To be fair to everybody,
Okay.
You want to listen to you, there's 100 packs, that's excellent. So next question from Mr. Muhammad Zaki Udian Roslan. Please go through it, take your time, James, go through the question and please answer the question directly. James?
Okay, so sure, no problem. So we have one from Muhammad Zaki Izzuddin. And here he says here from the industrial point, rapid growth. Okay, I think everyone can read it. So just let me read it as well, and then I'll answer it. So if I'll just mention the name of the person asking the questions. So I hope everyone can refer to the chat box, and then I'll answer accordingly. Okay, perfect. However, current technology inverter seems a bit difficult to produce the most cost-effective for any future plans. Okay, I think this is a very subjective question. Of course, in terms of cost effectiveness, we are always looking to push the envelope further. But as you know, every advancement, of course, there are its additional costs. But I am proud to say, or happy to say that we are pleased to say that we will be releasing our 8th generation inverter by the end of this year. Yeah, correct. So we're looking at the 8th generation, and it will be ready for energy storage as well. So stay tuned. I can't release too much information now because we're still patent pending. Yeah, but yes, definitely we are looking into addressing this. But it's very, very unique. Even to be honest with you, I thought that maybe inverter technology, we've come to a certain level where we can't innovate any further. But Huawei has proven me wrong as well. Okay, so the next question we're going to now is Langgaruman. I do apologize. I do know, Izzuddin, that this may not really answer your question. But like I said, towards the end of the year, I may be able to give you more information. Okay, I hope that satisfies it. Okay, so we have the other one from Langgaruman. Okay, what are the advantages of the optimizer? An optimizer is being installed. Okay, good question. This is from Dr. Zafran. Optimizers, we don't really see the need for it because large scale, you don't have a lot of shading factors. So in reality, I don't see what the optimization cannot be done through the MPPT instead. So for us, we always consider always 2 strings per MPPT. So that level of optimization is sufficient for large scale. Whereas for rooftop, because you only have so many collectors, so many panels, it is worthwhile to consider optimizers, especially because of the different orientation of the rooftop. Yeah. So I hope that answers your question. The next question is from Atika. What's the weight of a modern inverter? Is it going to be lighter in weight? Okay, right now, as it stands, we are less than 100 kilograms, that's for sure. So I think that is pretty good. Given right now, our biggest inverter we have for large scale is 215. So 200 kilowatt rated at 40 degrees Celsius. And of course, for the rooftop, it's only 100 kilowatt, but it's sufficient to do the job for rooftop, kind of a scenario. Yeah. But yes, in the modern inverter that we're envisioning, it would be interesting. Again, sorry, I think that one we will have another session with you all if necessary, in order to give you more information as we release it. Okay, is there a specific recommendation of DC AC ratio? And this is again from Encik Izzuddin. So generally speaking, it really depends on what you're trying to do. Large-scale systems, they always like to do this 1.5 DC-AC ratio. In reality, it is not really 1.5 because they do install additional inverters, so it may be actually down to 1.3. A good example of that would be actually the DNB Sepang one, or any of the other LSSs. What they do is that they install additional inverters for 2 reasons. One is for reactive power compensation. Alright, so the additional inverters act as your cap bank, but at the same time, because we know that our grid is pretty strong, thankfully, so we don't need those reverse cat banks actually. So it's really a wasted investment. So why not invest it on inverters, which will give you higher yield during the morning when it's low irradiation and during the afternoon when it's low radiation. So you're basically making your curve fatter as opposed to a nice bell curve. Now it's going to be like a mountain, kind of a curve like that, a flatter curve. Yeah, so I hope...
Yes, we have 10 more questions, 10 or 11 more questions. You have to be more precise.
Okay. Sure. Okay, so next one, again from Izudin. Wow, Izudin, you've got a lot of questions. No problem, we can talk again later. But okay, for the tracker systems, full solution from Huawei. Well, the tracker system in and of itself is not from Huawei, nor is the motor and so on and so forth. But what it does is that it's able to couple with our inverter and our communication system in order to provide that value add. Yeah, so it's not actually from Huawei, so it's integration of different components. All right, Insurance One asked, floating solar FPV, yes, okay. Hydrogen sulfide decay, okay, yep. This leads to severe corrosion metal parts. Okay, right now as it stands, the most harsh condition that our inverters have been recently installed is the one in Seletar Brau. Anyone knows where that is? It's between Singapore and Johor. Some geography trivia there for you all. Okay, so this is actually a 5 megawatt system, and it's just off the shore of Singapore. So our inverters are C5 rated, C5 medium. Yeah. So again, there are different classifications of corrosion testing. So you need to be sure when they talk about C5 which level of testing is done. Yeah. So that I hope that answers your question as well. But so far for our floating PV systems in China that we've done, we've not seen any issues thus far. But like I said, FPV is still fairly new, so we don't really have sufficient data to give you firm analysis. Okay, the next is from Dr. Najib. In open space, installations large scale, one significant problem comes lightning strikes. Yes, correct. Okay. An intelligent approach predetermine this occurrence. Okay, I think a key thing is of course don't always make sure that you have good lightning protection system. Whether you do a equipotential earthing grid or if you wanted to use a passive earthing system, again, this is subject to the EPC and consultant to decide. But as long as you've catered for that, our inverters, SPDs will do the rest of the job for the induced current. Yeah. So I hope that answers your question, Dr. Najib. And you saw the video earlier. I think that helps to prove it. Okay, Jayraj. Okay, microinverters. Believe it or not, I've dabbled in this during my time as an EPC. At that time, it was like that big and it's quite heavy, and it made the panel a whole lot harder to install. But microinverter technology, we don't see really the need for it because one of the things I found when I was installing microinverters is that your AC cable is limited. You will need a very thick cable if your rooftop or your cables are running very far. The farther the distances, then your cables will increase again in terms of size. Then it really makes it not so practical. So I'm assuming, Jayraj, that your microinverter, you're talking about the one that changes it to AC modules basically. So it's at the module level. So the short answer is no. We use our optimizers instead to try to address this one. Okay, this is from Raihan. How Huawei inverters smart in addressing multiple orientation. Okay, so multiple orientation, as I mentioned, through optimizer or our MPPT. Bifacial modules is mainly about the current, high current. So, and of course, through the MPPTs, it will also help with the current mismatch. Because bifacial, the very good question about bifacial, because the back has not equal or uniform exposure. So again, there has to be a level of optimization there, and that's why we always do only 2 streams per MPPT. So that will increase or improve that. Cost in terms of RM per kilowatt AC, maybe we can talk on the side here, because of course, it's subject to this, how your project is also. There's Huawei inverter available for hybrid. Okay, I think if you look at one of my webinars that I recently did in December for our launch of residential system, we do have a so-called, I'm not sure your hybrid is for what, but we have a residential hybrid whereby we can have a sort of like what we call a backup box that enables it to run apart from a grid. When the grid fails, it still can generate, but it's meant for critical load. If you're talking about off-grid, we also do have that solution. We have done it for Saris 4B in Sarawak. We're doing quite a lot more there. But that is also a different inverter technology altogether. So again, just to answer your question, I hope I did. If not, please do give me more information and I can address it accordingly. Izudin, once more, if we want to have string monitoring, then can we have full solution monitoring from Huawei also? It's compatible. Oh yeah, most definitely. We don't only provide you the hardware, we also provide you the monitoring solution. Like I said earlier, the IV curve is a subscription kind of a thing, but it's run off our software, our monitoring. Okay, any length limitation for M-bus communication? Very good question. Yes, there is. The last I checked is that if you wanted it to go to 1 km, then if you're using single core, you have to bundle it every few meters because of, again, the interference, because of the way how the cables are wrapped, and so on and so forth. So again, maybe Heng Chun, you can ask me offline, because I have to go in a little bit more depth, which this time does not permit. Okay, let's look at Zul Hilman. SPDs, should we add up additional? Okay, so this is the part where I think MS1837, I'm trying to update this, because for us, we believe that there's no additional requirement for DC and AC SPDs. Only at the MSB level, yes, please do go and put another SPD there, because again, we're trying to protect different sides of the cable and as well of the components here. Okay, so but in and of itself, our SPD in terms of AC and DC are capable of withstanding, as you saw from the video earlier. Okay, Professor Maliki. Hi, Dr. Maliki, how are you? Okay, Huawei datasheet, there are two maximum input currents, MPPT and short circuit current. Okay, could you explain the purpose of these currents? Okay, so as you know, panels again have also short circuit current and also IMP and ISC. So these two ratings are correspondingly to the panel. So ISC is when the occurrence of a short circuit, this is what the maximum current that will be discharged, or that will actually be channeled through. Okay, so that's why we always keep a 2-string per MPPT design, because if one were to be severed, the backfeed from the other string, which is complete, will only be as high as the module's current rating. Yeah, and I think that's why at least that one we were able to amend in the MS1837, which is as long as there's 2 strings, no more than 2 strings per MPPT, then you do not need a fuse to be included in the DC combiner box. Okay, question 2. Can we oversize Huawei inverter? Recommended oversize? Oh, similar to earlier. I think this is not only a technological question, it's also a commercial question, because I personally feel that there's no point to oversize so much that your inverter is capped by the time you will have a peak shaving. There's no point that you're losing your potential for generation. But the other point I wanted to highlight earlier when I brought up about this high DC AC ratio is that the reason why solar farms do it is you want to cater for 20 years. So the panel will degrade within 20 years or 21 years or 25 years about 20%. So by the time that 20% is taken off, you still have a DC AC ratio of say 1.3, maybe 1.25, again with other factors involved. So when that happens, you're normalizing it or levelizing it by the time of the end of useful life of the plant. So there are various reasons why people actually do a high DC AC ratio. Okay, I hope that answers it. Does all models can perform? Yes, the IV curve the IV curve capability is actually built in because we have string level monitoring capability and we have all the sensors and string inputs. So therefore, yes, it can be done. Do all models of Huawei inverters perform IV curve tracing? If not, no. Okay, yes, I think they're similar or yeah. Okay. Question 4: do all models have AFCI? Good question. All our newer models will have AFCI. Ground fault circuit interrupter, we don't find that to be necessary because we have RCMU and we have there are a few other different features that are already catering for ground fault. So what we want to do is actually to have the serial arc, which is not addressed. Yeah, this is why AFCI is actually introduced, because serial arc is something which is very hard to detect. Yeah. So we tackle the most important and most crucial one, and which has a quite high occurrence. Ground fault, it usually the inverter will actually trip itself. It will actually go into a protect mode. We always do an installation check before it goes into production every morning. So there are different things, that are features that will enable to address this concern. But AFCI is important for serial arc. Can we program the smart welder to do automatic power correction? Okay, this one, yes. This one is through dry contact. We still need a second component in it. Maybe we can talk more about this offline. time again not permitting. And then can optimizer be used? Now, unfortunately, the optimizers actually, because we use also our power line cable communication to monitor and get information and to send information to the optimizer. So it is specific to Huawei only. Okay, TS Nur Azlan. What are the standards used in evaluating dynamic? There is an IEC standard. I think it was in the slide earlier. But ask me again, and I can share with you the I think it's 50360. It's one of those not your standard 61727 and 62116 and all those. This one's because it's specific to at the component level. But yeah, it's a EN50436 or something like that. You can check. If not, you can message me later. All right. And then Dr. Muhammad Najib, modern solar inverters coming with reactive power capability. Yes. What is the reference? Avoid revenue earning. What is the reference for Huawei to avoid less revenue earning? Okay. So as I mentioned earlier, the reactive power generally in our grid, fortunately, is usually only for standby purposes. So in revenue earning, therefore the inverter is actually free to generate more during the morning and during the evening, as I mentioned earlier. So I hope that answers your question in that regard. The next one is Professor Dr. Ahmad Farid.
Next question.
Oh, sorry, next question. Okay, NEM 3.0, owner self-consumption. Therefore, I believe Inverter. Yes, we have zero export capability, but this is at only one point of interconnection, meaning that if you're referencing from 1 meter, if you have multiple sites, then we will have to have a third party to negotiate. It's like almost a power plant controller to negotiate between the 1 meter to multiple feed-in points. Yeah. We've done a few projects. I can share more later in Shiri's one if you need for more information. And last but not least, Encik Hasno from UiTM, LS2. Okay, the project. Thank you for using our inverter. In life cycle management, cost of ownership of inverter is concerned, yes. Okay, so I think the question I answered earlier, we have the DMVGL report verifying at least 16 years of lifespan, and then the subsequent towards the end of life to do repairs. So actually, we are in the works of considering repairs as well to help with this. So definitely, we are definitely innovating, and we're going to address all these concerns along the way. But we still have at least time is still on our side for now. But yes, it's not something that we've not thought about for sure, and we're definitely looking into it in a serious way. Okay, so I think I have answered all the questions in the chat. I hope that I have done justice to your questions. If I have not, please contact me and I will try my best to answer you accordingly.
Yes, James. Thank you very much. Huawei apparently has time on its side, but for you now, time is off. But thank you very much for your entertaining presentation and entertaining all the questions. I will not have time to do some wrapping up here because we need to move on. And what I will do now is I would like to just say that looks like we need to have another session with James and Huawei, perhaps. Yeah, okay, so with that...
Sure, most definitely, more than happy.
Yes, I thank you again, James, for accepting our invitation in a short notice. And thank you for entertaining all the questions. And to all participants, thank you very much. With this, I pass back to Ms. Adik.
Thank you both, Prof. Sulaiman and Mr. James. It was very worth sharing sessions. Now we're almost at the end of